The morning of December 16, 1944, dawned cold and fog-shrouded across the Ardennes forest. German soldiers, their breath-forming clouds in the freezing air, crept silently through the dense Belgian woodland. They moved with the confidence of men who believed they held the element of surprise, and they were right, at least initially. Operation Wacht am Rhein, Hitler's desperate gamble to split the Allied armies and capture the vital port of Antwerp, had begun. What these Wehrmacht and SS soldiers couldn't have known, as they advanced through the snow-covered hills and narrow valleys, was that they were marching toward a rendezvous with a technology so devastating that it would fundamentally alter the calculus of modern warfare. Hidden in the storage depots behind American lines were hundreds of thousands of artillery shells unlike any that had ever been fired in anger. Shells that carried within their nose cones a secret that had cost the United States over $1 billion to develop and that represented one of the most closely guarded technological achievements of the war. The proximity fuse was about to make its unauthorized combat debut, and the German army was about to learn that the rules of artillery warfare had changed forever. The dawn of electronic death. To understand the revolutionary nature of what happened in the Ardennes, one must first grasp what traditional artillery warfare looked like. Since cannons first appeared on European battlefields, artillery had been a weapon of probability rather than precision. Shells would arc through the sky and impact the ground, their effectiveness limited by terrain, entrenchments, and the simple fact that soldiers who heard the whistle of incoming rounds had precious seconds to dive for cover. Even the most skilled artillery crews firing the most advanced guns faced an immutable problem. Their shells had to actually hit something or land very close to it to be effective. A shell exploding in an open field might send shrapnel flying, but most of that deadly metal would embed itself harmlessly in the earth. Soldiers in foxholes, behind walls, or lying prone in depressions had excellent chances of surviving artillery barrages. Studies had shown that it could take hundreds or even thousands of rounds to neutralize a single well-entrenched position. The proximity fuse changed everything. Developed in absolute secrecy by a consortium of over 100 American companies working under the direction of the National Defense Research Committee, the VT variable time fuse was a technological marvel that packed a miniaturized radio transmitter, receiver, amplifier, and detonation circuit into a space no larger than a man's fist. The device had to survive being fired from a cannon, enduring acceleration forces of 20,000 times the force of gravity, and then function flawlessly as it hurtled through the air at supersonic speeds. The concept was elegantly simple, but the engineering was extraordinarily complex. As the shell flew toward its target, the tiny radio transmitter would send out a continuous signal. When the shell approached any solid object, the ground, a building, a tank, or a dense concentration of troops, the radio waves would bounce back. The fuse's receiver would detect the changing frequency of the reflected signal, a phenomenon known as the Doppler effect, and when the optimal distance was reached, typically between 30 and 50 feet above the target, the fuse would detonate the shell. What happened next was slaughter on a scale that traditional artillery could never achieve. The unauthorized decision. As the German offensive crashed through the thinly held American lines in mid-December, panic rippled through Allied command. Entire divisions were being overrun. Communications were severed. The weather prevented Allied air superiority from making any difference. In the chaos and confusion, a fateful decision was made, though who exactly made it remains a subject of historical debate. Colonel Oscar Alfred Axelson, whose name would become associated with the deployment of proximity-fused artillery in ground combat, was among the officers who recognized that the crisis in the Ardennes demanded extraordinary measures. The proximity fuse had been used successfully against Japanese aircraft in the Pacific and against German V-1 flying bombs over England, but it had been strictly forbidden for use in ground combat in Europe for one overriding reason. If the Germans captured an intact fuse and reverse-engineered the technology, they could deploy it against Allied aircraft with devastating effect. But by December 1944, the strategic calculus had shifted. The Luftwaffe was a shadow of its former self, barely able to contest the skies over Germany itself. The Allies enjoyed overwhelming air superiority. More importantly, the German offensive threatened to accomplish what Hitler had been unable to achieve since D-Day: the destruction of major American and British forces and a potential negotiated peace that would allow Germany to focus entirely on the Eastern Front. Someone, whether it was Axelson alone, acting under the authority of field commanders, or as part of a coordinated decision at higher levels, ordered that the proximity fuse be released for use against German ground forces in the Ardennes. Within days, orders went out to artillery units. Bring forward the special shells marked with distinctive colored bands and prepare to fire them in support of infantry under attack. The Americans were about to unveil their secret weapon, and they were about to do so against an enemy who had no idea what was coming. The technology of terror. Before a single proximity-fused shell was fired, tens of thousands of them had to be manufactured, and doing so represented one of the great industrial achievements of the war. The production challenge was staggering. Each fuse contained 5 miniature vacuum tubes, sophisticated electronic components that normally required careful handling and were fragile enough that simply dropping one would destroy it. These tubes had to be redesigned and re-engineered to survive the shock of being fired from a cannon. The solution involved innovations in materials science, manufacturing processes, and quality control that would have seemed impossible just years earlier. Companies like Raytheon, Sylvania, and dozens of others worked around the clock, often without knowing what their components would ultimately be used for. Security was so tight that workers in one factory producing parts had no idea how their components fit into the larger system. The various pieces were assembled at centralized facilities, and each completed fuse underwent rigorous testing. By December 1944, American factories were producing approximately 40,000 proximity fuses per day, an astounding feat of mass production for such a sophisticated device. The total program cost exceeded $1 billion, equivalent to roughly $15 billion today, making it one of the most expensive military development projects of the entire war, comparable in cost to the Manhattan Project. The shells arrived in Europe by the hundreds of thousands, each packed in protective casing and marked with distinctive identification codes. Artillery crews received special training, though. They were not told exactly how the fuses worked, only that these special shells would detonate at a specific height above the ground and that they should expect dramatically improved effectiveness. They had no idea just how dramatic the improvement would be. First blood, the Sour River. The first confirmed large-scale use of proximity-fused artillery in ground combat came along the Sour River in Luxembourg, where elements of the German 5th Parachute Division were attempting to cross under cover of darkness and fog. American artillery observers, using sound and flash ranging techniques, detected the concentration of German forces on the far bank and in boats attempting the crossing. The order went out: fire proximity-fused shells. What happened next was witnessed by General George S. Patton himself, who had arrived at the sector to assess the German threat. As the first salvo of proximity-fused rounds arced overhead, their distinctive whistle was no different from standard high-explosive shells. But when they detonated, the difference was immediately, horrifyingly apparent. Instead of impacting the ground and sending shrapnel in a cone-shaped pattern, the shells exploded in the air directly above the German positions. Each detonation created a lethal sphere of steel fragments that rained down on the soldiers below. There was no cover, no protection. Foxholes became death traps. Soldiers lying prone found themselves exposed from above. Trees, which normally provided some protection from ground-burst artillery, became surrounded by killing zones. When American forces advanced after the barrage, they found a scene of utter devastation. Bodies lay in heaps, many showing no visible wounds from the front or sides but bearing the distinctive marks of shrapnel that had struck from above, wounds to the tops of heads, shoulders, and backs. Equipment was shredded. Boats intended for the river crossing were riddled with holes. Patton, a man who had witnessed the carnage of 2 world wars and was hardly squeamish about the realities of combat, was nonetheless impressed by the sheer effectiveness of the new weapon. According to reports that would later be verified, American artillery had killed 702 German soldiers in a matter of minutes. The crossing was abandoned. The German offensive in that sector stalled before it had truly begun. Word began to spread among American artillery units. The new shells worked, and they worked better than anyone had dared hope. Bastogne, death from above. The true test of the proximity fuse came at Bastogne, the Belgian crossroads town that became the focal point of the German offensive. The 101st Airborne Division, along with elements of other units including the 463rd Parachute Field Artillery Battalion, found themselves surrounded by German forces on December 20th. Cut off from supply and reinforcement, the American defenders were in desperate straits. The Germans, confident in their numerical superiority and convinced that the Americans would surrender, prepared for what they believed would be the final assault. SS Panzer divisions and Wehrmacht infantry regrouped in the forests and villages surrounding Bastogne, massing for attacks designed to overwhelm the American defenses through sheer weight of numbers. They were concentrating exactly the kind of target that proximity-fused artillery was designed to destroy. The American artillery units at Bastogne had limited supplies of the special ammunition, but what they had, they used with devastating effect. The 463rd Parachute Field Artillery, commanded by officers who understood the value of the new fuses, allocated them carefully for moments of maximum impact. When German formations emerged from the tree lines to assault American positions, they encountered something they had never experienced before. Artillery fire that would normally have sent them diving for cover or scattering into the forest now followed them everywhere. The airbursts transformed open ground into killing fields, but even more critically, they made forests, traditionally havens for infantry under artillery fire, into chambers of death. The proximity-fused shells would detonate at treetop height, and the combined effect of the shell's fragmentation and the splintered wood from the trees themselves created a storm of shrapnel that no soldier could survive in the open. German units that advanced across open ground died in windrows. Units that retreated to the forest found no safety there either. One American artillery officer described watching through binoculars as a proximity-fused barrage caught a German company in the open. They simply ceased to exist as a military unit. One moment there were men advancing in formation. The next moment the air above them was filled with black bursts, and when the smoke cleared, there was nothing but bodies on the snow. We had never seen anything like it. The psychological effect on German troops was profound. Soldiers who had survived years on the Eastern Front, men who had endured some of the most brutal combat of the war, began reporting that the American artillery had become unbearable. Prisoners interrogated after capture spoke in awed, frightened terms about shells that exploded in the air without warning and against which there was no defense. German commanders, accustomed to calculating acceptable casualty rates for offensive operations, found their mathematics rendered obsolete. Attacks that they expected would suffer perhaps 15 or 20% casualties were being annihilated 60, 70, 80% losses in a matter of minutes. Units were being rendered combat ineffective before they could even close with American positions. Malmedy and the breaking of the SS. The effectiveness of proximity-fused artillery was perhaps most dramatically demonstrated against German elite formations. The 1st SS Panzer Division, one of the most feared units in the Wehrmacht, found itself repeatedly stymied by American artillery as it attempted to advance through the northern shoulder of the Bulge near Malmedy. The SS, accustomed to aggressive tactics and willing to accept heavy casualties in pursuit of objectives, discovered that their usual methods were suicidal in the face of this new weapon. Armored vehicles could survive the airbursts, but the infantry that accompanied them could not. Tanks advancing without infantry support were vulnerable to American anti-tank teams. Infantry attempting to advance without armor were cut down by proximity-fused barrages. The result was a tactical stalemate that quickly turned into a strategic defeat. The SS divisions, which Hitler had counted on to spearhead the breakthrough to Antwerp, found themselves bogged down, suffering mounting casualties without making corresponding gains. German commanders began requesting permission to withdraw, something almost unheard of in SS units. American artillery commanders, recognizing the effectiveness of their new weapon, began employing tactics specifically designed to maximize the proximity fuse's lethality. They would wait until German forces were caught in the open, crossing fields, moving through villages, or deploying from forests, and then would saturate the area with proximity-fused shells. 1. Particularly effective technique involved firing a mix of standard and proximity-fused shells. The ground bursts would force German soldiers to take cover, and then the airbursts would kill them where they lay. Artillery officers began referring to it as bouncing the rubble, first destroying buildings and cover with ground bursts, then killing anyone who survived with airbursts. The Germans had no effective countermeasure. Their own artillery, firing conventional shells, could not achieve similar effects. Even when they captured American artillery positions and examined the shells, The complexity of the proximity fuse and the destruction often inflicted on captured specimens meant that German engineers could not quickly reverse-engineer the technology. The mathematics of death. The true revolutionary nature of the proximity fuse lay not in any single engagement but in the fundamental change it brought to artillery warfare's mathematics. Traditional artillery effectiveness could be calculated based on the circular error probable, CEP, the radius of a circle within which half of all shells fired would land. For World War II artillery, this was typically measured in dozens of yards, even for the most accurate guns. With proximity fuses, the CEP became almost irrelevant. As long as a shell passed within its detonation height of the ground, typically 30 to 50 feet, it would detonate at optimal effectiveness. This meant that shells that would have been misses with traditional fuses became devastating hits with proximity fuses. Studies conducted after the battle showed that proximity-fused shells were approximately 5 times more effective per round than traditional artillery. But the real force multiplier came from the fact that artillery. This meant that shells that would have been misses with traditional fuses became devastating hits with proximity fuses. Studies conducted after the battle showed that proximity-fused shells were approximately 5 times more effective per round than traditional artillery. But the real force multiplier came from the fact that artillery units could fire fewer rounds to achieve the same effect, could do so more quickly, and could engage targets that had previously been difficult or impossible to neutralize effectively. A traditional artillery barrage might require 500 to 1,000 rounds to neutralize a dug-in infantry company. With proximity fuses, the same result could be achieved with 50 to 100 rounds. This meant that American artillery units could engage more targets, respond more quickly to calls for fire support, and maintain sustained fire for longer periods without exhausting their ammunition supplies. The cumulative effect on the Battle of the Bulge was staggering. Conservative estimates suggest that proximity-fused artillery inflicted between 15,000 and 20,000 German casualties during the battle, roughly 10 to 15% of all German casualties in the Ardennes offensive. But the tactical impact was even greater than these numbers suggest, because the casualties were inflicted disproportionately on German units at critical moments, during attacks while concentrating for assaults, or while attempting to exploit breakthroughs. Patton's relief of Bastogne. When Patton's Third Army turned north to relieve Bastogne after Christmas, proximity-fused artillery played a crucial role in breaking through German defensive positions. The weather had cleared enough to allow some air support, but it was American artillery, firing thousands of proximity-fused shells, that carved the path for Patton's armor. German positions that would normally have required sustained bombardment followed by infantry assault were neutralized in minutes by proximity-fused barrages. German commanders reported that their troops were increasingly reluctant to hold positions that were under threat from American artillery, knowing that there was essentially no protection from the airbursts. When the first tanks from Patton's 4th Armored Division reached the perimeter of Bastogne on December 26, they did so largely because American artillery had systematically dismantled every German defensive position in their path. The relief of Bastogne, often portrayed in popular history as primarily a feat of armored warfare, was in reality a demonstration of how technological superiority in artillery could enable maneuver warfare. The German offensive, which had begun with such promise on December 16, was effectively over. Hitler would continue to demand attacks and counterattacks for weeks, but the momentum had been irretrievably lost. The proximity fuse had not single-handedly defeated the German offensive. American tactical skill, German logistical problems, improved weather allowing air support, and the fundamental overextension of German forces all played roles, but it had tipped the balance at crucial moments and dramatically increased the cost of every German tactical decision. Eisenhower's assessment. After the battle, General Dwight D. Eisenhower, the Supreme Allied Commander, made a remarkable statement about the proximity fuse. In discussions with senior officers and war planners, Eisenhower declared that if Germany had possessed proximity-fused artillery during the D-Day landings, the invasion might well have failed. This was not hyperbole. The beaches of Normandy had been bracketed by German artillery, but the effectiveness of that artillery had been limited by the same factors that limited all artillery: the need for direct hits or very near misses to inflict casualties. American and British troops had been able to advance by using cover, by moving quickly between bombardments, and by accepting that a certain percentage of artillery rounds would simply miss their targets. With proximity fuses, the equation would have been entirely different. Artillery firing airbursts over the beaches would have turned the landing zones into killing fields. Landing craft would have been vulnerable from the moment their ramps dropped. Troops crossing the beaches would have had no cover from artillery that detonated overhead. The carefully planned naval and air bombardments that preceded the landings might not have been sufficient to neutralize German artillery positions before they could fire enough proximity-fused shells to devastate the assault waves. Eisenhower's statement underscored a fundamental truth that the Battle of the Bulge had demonstrated. Technological superiority could trump numerical superiority, tactical skill, and even strategic position. The side that possessed proximity fuses had a weapon that fundamentally changed the nature of ground combat, and the side that lacked them was at a potentially insurmountable disadvantage. The end of an era. The deployment of proximity fuses in the Battle of the Bulge marked a turning point in military history. For centuries, warfare had been primarily a contest of tactics, strategy, logistics, and the courage and skill of individual soldiers. Technology had always played a role, but it had been relatively incremental: better guns, better armor, better communications. The proximity fuse represented something different. A quantum leap in capability that gave one side an overwhelming advantage in a fundamental aspect of warfare. It was a preview of the military technological revolution that would accelerate after World War II and that continues to this day, as precision-guided munitions, drones, electronic warfare, and artificial intelligence transform battlefields. For the German soldiers in the Ardennes, the proximity fuse was a terrifying and inexplicable mystery. They had no frame of reference for artillery that consistently exploded at optimal height above their positions. Many believed initially that American artillery observers were somehow able to see their exact positions and were setting timed fuses with impossible precision. Others thought it might be some new type of bomb dropped by aircraft. The truth that American shells carried miniaturized radio transmitters that automatically detonated at optimal height would have seemed like science fiction. By the time German intelligence pieced together what was happening, the battle was lost. The German army would continue to fight with desperate skill and determination for 4 more months. But the Battle of the Bulge had proven beyond doubt that Germany could not win through tactical excellence alone. The technological and industrial gap between Germany and the United States had become too great to bridge. Legacy. The approximately 200,000 proximity-fused shells fired during the Battle of the Bulge represented just a tiny fraction of the eventual production. By the end of the war, American factories had produced over 20 million proximity fuses. They would be used in every theater of war, against targets ranging from Japanese aircraft over the Pacific to German V-1 flying bombs over England to ground targets across Europe and Asia. The technology developed for the proximity fuse would have far-reaching peacetime applications. The miniaturization techniques used to create vacuum tubes that could survive 20,000 G-forces contributed to the development of more robust electronics. The mass production methods developed to manufacture millions of complex devices with high reliability helped lay the groundwork for the electronics industry that would emerge after the war. But the most important legacy of the proximity fuse was strategic and tactical. It demonstrated that, in modern warfare, technological superiority could be decisive. It showed that industrial capacity and scientific research could create weapons that fundamentally changed the nature of combat. And it proved that in a world of rapidly advancing technology, the nation that could harness its scientific and industrial resources most effectively would have an overwhelming military advantage. Conclusion. The German soldiers advancing through the Ardennes forest in December 1944 were brave, skilled, and determined. Many were veterans of years of brutal combat. They had survived the Eastern Front, Italy, North Africa, and countless other battlefields. They were led by experienced officers and fighting for their homeland. None of it mattered when American artillery began firing proximity-fused shells. The technology was too revolutionary, the advantage too overwhelming. In the frozen forests and snow-swept fields of Belgium, the nature of warfare changed. The age of technological dominance had arrived, announced by the deadly black bursts of proximity-fused shells exploding 30 feet above German positions. The Battle of the Bulge would be remembered for many things: the defense of Bastogne, Patton's dramatic relief force, the bitter cold, the nuts reply to German surrender demands. But perhaps its most important legacy was demonstrating that in modern warfare, The side with superior technology doesn't just have an advantage. It has the power to render traditional military virtues of courage, tactical skill, and determination almost irrelevant. The Germans were indeed surprised when proximity fuses wiped out entire formations at the Battle of the Bulge. But surprise quickly gave way to the grim realization that they were facing a weapon against which they had no effective defense and no ability to respond in kind. The tiny radio transmitters in those shells, products of American industrial might and scientific ingenuity, had accomplished what entire armies might not have. They had broken the last great German offensive and helped ensure Allied victory in Europe. The secret was out, and warfare would never be the same.